Air travel is the fastest means of transportation on the planet. But what if we could travel faster? How would you like to be able to catch a lunch meeting in Paris and still make it back to New York for dinner with your family? By flying at greater speeds higher in the atmosphere, commercial planes would be able to fly faster than the speed of sound or supersonic. The time for a conventional 7-hour flight could instead be cut in half. The business world could be seeing supersonic jets by 2013. However, significant regulatory, industrial, and environmental challenges stand in the way. Some of the main concerns regarding supersonic flight are the shockwave that is created, the required materials for the aircrafts, and the sonic boom that results from traveling at these high speeds. As you can see, this capsule is re-entering the atmosphere. The white shield in front of the spacecraft is called a shockwave. This natural phenomenon protects the spacecraft's body from absorbing a significant amount of heat created while traveling through the atmosphere. To further understand the concept about shockwaves, we interviewed Dr. Alexandre Martin. Dr. Martin is one of the University of Kentucky's top aerospace engineering researchers and a former invited researcher at NASA Ames.
You have this high velocity which causes that when you enter the atmosphere you develop a strong shock wave in front of your vehicle. So that shock wave will get your temperature very, very high, change the composition of the gas, and also emit radiation, and this will all affect your vehicle. And this is going really, really, really fast. So you have all sorts of physical process that you don't have necessarily if you have an equilibrium, a very slow process, and this goes, so you need to account for all of that when you're trying to because it allows you to heat up your gas very, very quickly, and you design your vehicle so that it dissipates that energy around your vehicle and doesn't go through.
The materials used to make today's jets might not be able to withstand these demanding conditions. To prevent the destruction of the aircraft, the body needs to be covered with a material durable enough to withstand these extreme conditions. Titanium alloys are some of the strongest materials with the best strength-to-weight ratio. Tested at temperatures up to 1800 degrees Fahrenheit, titanium alloys can endure the mechanical and thermal intensities that an aircraft is exposed to during supersonic flight. Using materials more efficiently is the key to reducing costs. With any given material, cost reduction can be achieved in two ways. 1. Redesigning to use less materials, and 2. Using better manufacturing processes. This would ensure the safety and comfort of the passengers during flight. Here is an example of a sonic boom. When the aircraft is traveling above the speed of sound, the shape of the aircraft creates areas of high pressure in the air, similar to how boats leave wakes in water. When the fast-traveling air passing over the wings meets the low-pressure pocket created by the back of the aircraft, a huge pressure difference is created. When this area of disturbed air reaches the surface of the Earth, the sound it produces is equivalent to a loud explosion. NASA is currently researching how the geometry of the aircraft could break up the one large sonic boom into several smaller sonic booms. These smaller booms would make the resulting sound much quieter compared to current supersonic aircrafts. Under current regulations, no aircraft is allowed to travel at supersonic speeds over land. This is due to the disturbance caused by the sonic boom. With this new technology, hopefully these regulations can be lifted to allow supersonic flight. This would make supersonic air travel more practical and open up more air highways. There are two companies that are already in the process of designing supersonic business jets, allowing it to become a more feasible means of transportation. Ariad Corporations and Supersonic Aerospace International are two companies who are developing aircrafts to be made from cheaper titanium alloys, quieting the effect of the sonic boom and utilizing the shockwave for supersonic flight. The world is on the verge of the next major breakthrough in transportation, but much more experimentation is needed. But when they do figure it out, I'll see you in Paris.